NASA will use futuristic electric thrusters that produce a blue glow to power the spaceship that will launch to the metal-rich asteroid Psyche in 2022, which is estimated to be worth more than $10,000 quadrillion. In 2026, NASA will launch a mission to explore the Psyche asteroid. It is an asteroid belt object between Jupiter and Mars that is 124 miles across, as big as the state of Massachusetts. Psyche is full of metals worth about $10,000 quadrillion. It's 10,000 with 15 zeros behind. Unbelievable, isn't it? If returned, it would make everyone living on Earth a billionaire and destabilize the world economy. According to the NASA, to reach the asteroid, the spaceship will employ xenon and solar electric engines. As the spacecraft accelerates to 200,000 miles per hour, these will release a beam of blue light. The first high-resolution measurements of the surface temperature of asteroid Psyche confirms it is packed full of $10,000 quadrillion worth of precious metal. Next year, NASA will send a spacecraft to the metal-rich asteroid Psyche with a cutting-edge propulsion technology that produces a cool blue glow. The odd rock, which some scientists believe might be the core of a long-destroyed planet from early in the history of the solar system, will be explored by the spacecraft, which is being created by NASA's Jet Propulsion Laboratory in Pasadena, California. The spacecraft, also known as Psyche, will launch in August 2022 and travel 1.5 billion miles in 3.5 years to reach the space rock, where it will land in 2026. And before we go on, if you like this kind of enticing Luxinside's videos, please subscribe, like, comment and put the notification bell on if you don't want to miss our next weekly videos. This technology creates a very gentle thrust but has never been deployed in a spaceship that travels beyond the moon. Its pressure is comparable to what you would experience when holding 3 10p pieces, but despite the low pressure, it is enough to accelerate Psyche through deep space. The spacecraft will eventually accelerate to speeds of up to 200,000 miles per hour, helping it in reaching Psyche because there won't be any atmospheric pull to slow it down. The asteroid is 230 million miles from Earth, but the total distance traveled will be 1.5 billion miles because of the requirement for flybys to use Mars' gravity as a boost. To fly off the launch pad and escape Earth's gravity, the spaceship will rely on the chemical rocket engines of the SpaceX Falcon Heavy launch vehicle. But the rest of the journey, once Psyche separates from the launch vehicle, will rely on solar electric propulsion. This form of propulsion starts with large solar arrays that convert sunlight into electricity, providing the power source for the spacecraft's thrusters. According to NASA JPL, its propulsion technology, also known as Hall thrusters, is so effective that it could run continuously for years without running out of fuel. Throughout its journey, Psyche will have 2,030 pounds, 922 kilograms of xenon in its tanks. According to NASA engineers, the project would require nearly 5 times as much fuel if it had to utilize conventional chemical thrusters. They also note that Hall thrusters were intended for the mission from the beginning. According to Lindy Elkins-Tanton, the project's main investigator from Arizona State University in Phoenix, solar electric propulsion was a part of the plan, even when we were first developing the mission in 2012. Elkins-Tanton stated, "Without that, we wouldn't have the Psyche mission," adding, "It's become part of the character of the mission. It takes a specialized team to calculate trajectories and orbits using solar electric propulsion." Psyche will launch from the historic Pad 39A at NASA's Kennedy Space Center in Florida, where it will first fly by Mars for a gravity assist in May 2023. In early 2026, the thrusters will do the delicate work of getting the spacecraft into orbit around asteroid Psyche, using a bit of ballet to back into orbit around its target. That task will be especially tricky because of how little scientists know about the asteroid, which appears as only a tiny dot of light in telescopes, the team said. Ground-based radar suggests it's about 140 miles, 226 kilometers, wide and potato-shaped, which means scientists won't know until they get there how exactly its gravity field works, making orbital insertion particularly difficult. As the mission conducts its science investigation over 21 months, navigation engineers will use the electric propulsion thrusters to fly the spacecraft through a progression of orbits that gradually bring it closer and closer to Psyche. Similar technology was employed by NASA during the Deep Space One mission, which was launched in 1998 and completed in 2001 after passing past an asteroid and a comet. Next came Dawn, which used solar electric propulsion to travel to and orbit the asteroid Vesta and then the protoplanet Ceres. The first spacecraft ever to orbit 2 extraterrestrial targets, the Dawn mission lasted 11 years, ending in 2018 when it used up the last of the hydrazine propellant. For decades, Maxar Technologies, which built the chassis and the propulsion system, has used solar electric propulsion to power commercial communications satellites. Nevertheless, deep space travel needs certain modifications. JPL engineers were called upon to modify the extremely efficient Hall thrusters in order to travel in outer space. Both teams anticipate that the use of Hall thrusters by Psyche, which will do so for the first time outside of lunar orbit, will assist to push the boundaries of solar electric propulsion. Once in orbit, the mission crew will employ the research payload to look into what this particular target may tell us about how rocky planets like Earth, Venus, Mars, and even as yet undiscovered exoplanets like our own were formed. Scientists think that Psyche, unlike most other asteroids that are rocky or icy bodies, is made up of mostly iron and nickel, and even gold similar to Earth's core. The Psyche team will measure the asteroid's magnetic field using a magnetometer. Images of the surface as well as information on Psyche's composition and topography will be taken by a multispectral imager. Neutrons and gamma rays emitted from the surface will be examined by spectrometers to identify the components of the asteroid. And that's all for today's video, and don't forget to smash the subscribe button and hit the notification bell for more exciting Luxinside's videos. Thanks for watching.